So this video is going to be about Boyle's Law. So Boyle's Law is named after a former famous scientist who did extensive work on gases, and this is one of our few gas laws. And what Boyle's Law does is it relates pressure and volume for a sample of gas. So when you are looking at Boyle's Law, you're looking at, if I adjust the pressure of my gas to this, what will happen to the volume? Or if I adjust the volume of my gas to this, what will happen to the pressure? And you'll see that it's a kind of a balancing act. So the equation that mathematically shows Boyle's Law, which we'll put down and then we'll talk about, is Boyle's Law is P1 V1 is equal to P2 V2. So, right, let's look at this a little bit more closely. What this is saying is that the pressure and the volume of our gas under our first set of conditions, that's kind of what the ones are for, our first set of conditions, is equal to the pressure and volume of the gas under our second set of conditions. So what does that mean? That means that the net of these two things multiplied together doesn't change. So if my pressure times my volume under conditions 1 is equal to my pressure times my volume to under conditions 2, that means that when we're talking about Boyle's Law, if pressure increases, then our volume will go ahead and decrease. Right? That's the only way that mathematically it will work out. And kind of on the opposite end, if pressure goes down, then volume will go up, right? So let's talk about this without numbers, and then we'll try an example problem. So imagine that I have a cylinder. There it is. And inside my cylinder is a piston that lets me kind of compress the space of my cylinder, right? So I can move this thing up and down underneath it is my gas. Right? So right now this gas exists at my P1 and my V1, right? The pressure and the volume have to be the same. I don't have to be the same. The pressure and the volume are set with this piston way up here. And then let's say that I can move my piston. So let's say I go ahead and I do that. So here's my cylinder again, not quite the same size, but that's not the point. And now I've moved my cylinder way down near the bottom. My piston has been moved all the way down near the bottom. And now my gas is in this tiny little area. Right? So now it's P2 and V2. But remember what Boyle's Law says, right? Boyle's Law says that the product of pressure and volume has to always stay the same. So think about this. Volume clearly decreased. Right, we went from this big space to this little tiny space. So the only way that volume could decrease that much is if pressure increased, right? So we had it at one set pressure before, and then when our volume went down, our pressure must have gone way up. So volume goes down, pressure goes up. Now think about why pressure would go up when our gas gets confined to a smaller space, right? Well, our gas is really, right, we kind of just wrote gas in there for simplicity, but our gas is really molecules of a gas, of a compound, of a substance, right? So that means that it's really little atoms or molecules floating around in there, right? Let's say there's 4 of them. Look at how much more space there is over here on the left than on the right. And remember what we said about pressure. Pressure is force over area, right? It's how frequently and how forcefully. It's the ratio. Pressure equals force over area. So it's the ratio of force and area for our gas molecules. So a smaller space is way more collisions of these molecules on the sides of the container than it is over here. Right? It's going to happen way less frequently with a bigger volume than with a smaller volume. So pressure and volume are going to be related that way, right? If pressure goes up, volume is going to go down. And if volume goes up, and if pressure goes down, volume is going to go up, right? So where volume went down, pressure had to go up to compensate. It's not that pressure decides out of the blue to go up to compensate. It has to by the definition of what's going on here with the molecules. So let's erase some of this. So if you want to pause the video and copy any of this down and write some notes down, that's fine. But if not, press play and resume. So we're going to erase some of this and look at a quick little problem. Let's make my eraser bigger. So we're going to take Boyle's Law, and we're going to show you what a problem would look like. So P1, V1 equals P2 and V2. Let's draw a big line, and then we'll work a nice little example problem on the bottom. So let's say that this is an example. Let's say a gas at pressure is equal to 1.5 atmospheres and volume equal to, let's say, 0.5 liters, is compressed, just going to abbreviate that, to a volume of, let's do 0.25 liters. Right, so we've got this gas that exists at a pressure of 1.5 atmospheres, and it is going to, and its volume is 0.5 liters, so it's in a fairly small space, and then it's being compressed into an either smaller space. So without even starting this problem, I can tell you that the pressure is going to go up. The reason why I can tell you that is our volume went down, right? So if volume is going down, pressure is going up. So let's set up the math and see how it works out. So when we're doing Boyle's Law equations, always a good idea to start by writing down the problem. And then we're going to solve this equation for P2 in a second. But let's plug our numbers in and we'll work it that way. Actually, you know, let's do this a little bit differently. Let's solve for the variable and then go back in and plug the numbers in. So I want to find P2, right? That's the question. We've got a pressure 1, we've got a volume 1, we've got a volume 2, we want P2. So we want to find this variable, so we have to isolate it. So we're going to divide each side by V2. They cancel out on the right. So rearranging, or just resetting that equation, P2 is going to equal P1 times V1 divided by V2. Right now it's just really a matter of plugging in our numbers and solving for our variables. So let's go ahead and start doing that. So our original pressure was 1.5 atmospheres, ATM, times our original volume, 0.5 liters, divided by our new volume, our compressed volume of 0.25 liters, right? So if volume goes down, pressure must go up. So if we're going to do our math here, 1.5 times 0.5 divided by 0.25 is going to give you a new pressure of 3.0 atmospheres. So see what we said? If volume is going down, pressure is going to have to go up. Our volume did in fact go down, so our pressure did in fact go up.